So in the previous video, we have seen the two important concepts, that is normal precipitation and average annual precipitation. So in this video now, we will be discussing the next and one of the most important part from hydrology, that is about estimation of missing data. So give the heading as estimation of missing data. So what is the meaning of missing data and what is the need of the estimation of missing data? So let's come back to the basics in this hydrology. So let's consider an area here. Okay, in the particular area there is a precipitation which is taking place. So for a reference, I am taking it as it is Maharashtra. Okay, a state in India. So in this we have four rain gauges. So 1, 2, 3 and 4. So we have total number of rain gauges are 4. So these four rain gauges are continuously taking the data, and if we take the data for last 35 years and if we take the average of that, so we will get the which value will get average annual precipitation, that is average of annual rainfall for last 35 years. Okay, so what we are seeing, we are taking the data. Let's say this is rain gauge 1, rain gauge 2, rain gauge 3 and rain gauge 4. Okay, so if we take the average of last 35 years, okay, if we take the average of last 35 years, the rainfall that we will get, or the precipitation that we will be called as average annual precipitation. Correct, average annual precipitation. If we take the data for last how many years, 30 years. So if we take the data for last 30 years, then this precipitation is called as normal precipitation. Okay, so here two symbols will be given in the problem. One will be P and one will be N. So whenever we will be using P, this P meaning will be average annual precipitation and N will be representing the normal precipitation values. I hope it is clear. Okay, so that means for each of this rain gauge, there are two values. One is the P value, P1, and second is the N1 value. Similarly for second gauge, P2, N2, P3, N3, P4 and N4. Okay, now see, for the last 35 years, if we are taking the data and if we are taking the average, that means we have to take the average of all 35 readings. Now in this last 35 years, let's say in 10th year, okay, so out of this 35 years, in 10th year there was some problem and the data we are not getting it, so the data is missing there. So we cannot take the average of last 35 years then if the data is missing. Now how the data can be missed? The data can be missed by, let's say the records are missing, the records have lost, or due to some sudden disaster the records are not, we are not getting the records. Okay, right now everything is digital, but the previous records, let's say that they were not digital, they were written manually in some books or some records, manual records. So due to some reason we are not getting the correct data for a certain year. So what we have to do is we have to estimate the data for that year based on the remaining values. That means if we have, let's say 1, 2, 3, 4, 5. Okay, so in a particular year, or let's say up to 5 years, there is one rain gauge here. This is second rain gauge. Okay, so this rain gauge data we don't have. That means this station records were not up to the mark, or we can say the data is not present at this rain gauge. So no one has taken the data from this rain gauge and we don't have the rain gauge data now. Okay, that means we do not have the value of precipitation, that is P value. Now, so in this case, how to measure the P value? So I'm just writing it here. So we have to find out P2 value. Okay, so this is our aim, to find out the value of P2. So what are the values that we know? So we know P1, then P3 and P4. In case of normal precipitation, all values will be given, that is N1, N2, N3 and N4. Okay. Now, in this case, what we have to do? We have to find out the value of P2. So this way of calculating the missing data is coming under the heading of estimation of missing data. I hope now you are getting an idea what we are trying to do here. Okay. So for analysis, we need two important things in a data. If we want to analyze any data, we need the two important things in a particular data. So the first thing is the data should be continuous. Okay. What is the meaning of continuous? That means there should not be any break in the data. If we are seeing the data for last 5 years, 1, 2, 3, 4 and 5, then the data, we should have the data of all the last 5 years. It is not like that we don't have the third year data, then we cannot say that the data is continuous. Okay. So what is the first thing? It should be continuous. And the second one is it should be consistent. Okay. So this data continuity, this can be achieved by using this estimation of missing data. If some data is not present, then we can find the missing data by using the formulas that we are going to see here. Okay. Now the second one is the data should be consistent. Now for this checking the consistency of data and to making it consistent, we have to use the method or a curve which is called as double mass curve. Very important. Okay, many times in IAS exam also directly the question is asked, which of the following is used for measuring the consistency of data? Very important from hydrology question. See, you don't have to draw this diagram also, you don't have to do anything. Just remember this one point. The consistency of rainfall data is measured by what? It is measured by double mass curve. Okay. So now what is the meaning of consistent? I hope you understood the continuous meaning. So continuous means, let's say that this is one initial area. Okay. Now in this initial area, as we know that as the time will pass, we are for calculating average annual precipitation, how many years are required? Previous 35 years are required. So in the starting of this 35 years, that is 35 years ago, let's say there was only forest here. Okay, in this area there was only forest, but after 20-30 years there may be certain road which is going on from this area. Okay, so you can say that initially there was no road which is going through our area, but now there is one road which is going through the area. So due to this inclusion of road in our area, there will be certain change in the data pattern. Okay, so to achieve the consistency, or we can say to achieve the present conditions with the previous conditions, we will use this double mass curve. So that is the meaning of consistent. Okay, so these are the two important things which should be required for analysis of data. Okay, coming to the main point now, how to estimate the missing data. So we have taken the example in the previous slide. So total 4 stations are there. In this 4 station, the rain gauge 2 is not working properly. Okay, so the precipitation value at that rain gauge we don't know. However, the nearby rain gauges are there, rain gauge 1, rain gauge 3 and rain gauge 4, which are working properly. Okay, so now with the help of the remaining rain gauges, we can find out the value of the rain gauge which is not working. So how to find out? So there are two methods which are used for finding or estimation of missing rainfall. So write down, there are two methods used for estimation of missing rainfall. Estimation of missing rainfall. So write down, the first method is simple method. It is also called as arithmetic mean method. So this is the first method. The second method is called as normal ratio method. So we'll be writing the direct formula here. Okay, so the main criteria here is, so just write it down, n value should be within plus or minus 10%. Okay, in this case n value, if not within n value if not within plus or minus 10%. So just remember this one. I will explain it to you what is it. So first write down the plus or minus 10 percentage band here. See, so plus or minus 10 percentage means either it can be 100 plus 10 or 100 minus 10. So 100 plus 10 it will be 110. So 110 percentage means we can multiply it 1.1, and this 90 percentage means we can multiply it by 0.9. So using the basic percentage concept, we can write it like this. So it is 1.1 times and 0.9 times. Just see what I am doing. Okay, the statement is like this, but while solving the problem you follow this method. So the first thing is to write down this 1.1 and 0.9. So then you multiply. So by what you have to multiply? You have to multiply by the n value of missing rainfall station. So in this case, which rainfall station or which rain gauge station is not working? This second rain gauge station is not working. What is the value of n here? The value of n is n2 here. So you multiply that by n2. So this we have to multiply with n2, and this also you multiply it with n2. Okay, so this is the first thing. Now what is the second condition? That the remaining n values, see we are multiplying with the n2 value. Okay, now the remaining values, that is n1, n3 and n4. So this should lie between this range. This should lie between this range, that is n1, n3 and n4. It should lie between 1.1 times n2 and 0.9 times n2. What is the meaning of this? So let's take a quick example. If n2 is 100, if n2 value is 100, what is the upper band? It is 110. What is the lower band? It is 90. That means this n1, n2 and n4, n1, n3 and n4, they should lie between 90 and 110. If it is lying between 110, that means the criteria for simple mean method is satisfied. That is n values should be within plus or minus 10 percentage range. So if it is taking place, okay, that is the values are between plus or minus 10 percentage, then we will use the simple mean formula, that is simple mean method. And what is the formula for this? Simple one, that is P2, that we have to calculate is summation of remaining precipitation. So what are the remaining? P1 plus P3 plus P4 divided by 3. So this will give us the simple mean method. By using the simple mean method, we will get the missing rainfall data. Okay, see in previously, just a minute. So in the previous slide we have seen that we have to calculate the value of P2. So this is how we can calculate the value of P2. So this is an important condition. After seeing the condition, apply the formula and you will get the answer. See, this condition has to be followed. If it is not between plus or minus 10 percentage, then we have to go for the normal ratio method. What is the formula for normal ratio method? We will just write it down. So it is P2 divided by N2. Okay, the second station data we have to find it out. So P2 divided by N2 is equal to 1 by remaining stations. So remaining stations are 3. So in this case I am writing here 3. 1 by 3 in bracket P1 by N1 plus P3 by N3 plus P4 by N4. Okay, So if you want to write it down in terms of x, you can write it as like this: Px by Nx is equal to 1 by m into P1 by N1 plus P2 by N2 plus and so on Pn by Nn, where m is equal to n minus 1, total number of stations minus 1. Okay, and what is the meaning of P? P means precipitation, or we can say average precipitation, and N is the normal precipitation. So with these formulas we can find out the value of missing rainfall. If a certain data is missing, then we can find it out, or we can estimate the data by using the nearby stations. Okay, so this is all about the estimation of missing data.